Ladies and gentlemen, good day and welcome to EU-Taiwan Smart Manufacturing webinar. Today, our event is held online. So, to begin our seminar, I would like to point out a fact that everyone, I'm sure, agrees. That is, EU is the world's #1 economy for industry and also especially for smart manufacturing. Now, as for Taiwan, we would like to say that we're doing a great job in smart manufacturing. In fact, in recent years, we're making wonderful strides, great strides in the area of smart manufacturing. So, we would like to also say that Taiwan is EU's best partner for smart manufacturing. And in fact, also the best partner for the world in smart manufacturing. Ladies and gentlemen, today in our webinar, we are inviting experts from Taiwan, from EU, to join us online and on-site right here in Taiwan to discuss and share ideas and experiences about smart manufacturing. And now, without further ado, I would like to welcome our host, ladies and gentlemen, for the opening remarks. Please welcome Director Lin Huayu from Taiwan's Ministry of Economic Affairs, Industrial Development Bureau.
Esteemed international guests, industry leaders, and friends online, welcome. It's with great pleasure and honor for me to have today's opportunity to greet everyone in different time zones and open for this year's EU-Taiwan Smart Manufacturing webinar. First of all, I would like to represent Taiwan's Industrial Development Bureau in welcoming EU and Taiwan industry leaders to share their insights and pioneering solutions for smart manufacturing. I hope through holding this forum can continue to develop closer industry relationship in smart manufacturing for both sides. The global industry is seeing an extraordinary shock in 2020. The future is full of unknowns and challenges. In the face of coronavirus impact and the resulting uncertain effects on the global supply chain, how enterprise from Taiwan and the European countries should react and change a potential predicament into a more positive outcome. This is a test for the government and industry to remain flexible in decision-making. Since 2016, Taiwan has accelerated efforts put into developing smart manufacturing, adopting AI, 5G, and IoT new technologies for smart manufacturing is therefore a critical goal for Taiwan in order to maintain industry competitiveness. The continued relationship and the exchanges between EU and Taiwan is very important to us. Post-pandemic, Taiwan and the EU can increase collaboration and find new market opportunity together. Our government is committed in aiding industry in advancing technologies in order to shape Taiwan into Asia's high-level manufacturing hub. I hope through exchanges with EU that we can learn new experience and best practices. Deepening collaboration efforts, we can fasten industry transformation and create a high-intelligent manufacturing ecosystem ready to face future market opportunities. I hope to see the EU and Taiwan can showcase exemplary results every year and reach new milestones. Since 2015, Taiwan and the EU seek to enhance cooperation and communication through conferences that not only improve the understanding of industry development, but also aim to increase business opportunities for both sides. I would like to thank everyone for your work in helping deep industry cooperation between Taiwan and the EU. I would also like to thank everyone for making time to attend in your busy schedules. It's because of your participation today that relationship between Taiwan and the EU can keep striving forward. Lastly, I wish for successful activity today and also continuous health, success, and prosperity for everyone. Thank you.
All right, thank you so much, Director Lin. Yes, the relationship between Taiwan and EU will keep moving forward. And now, ladies and gentlemen, joining us also for the welcoming remarks, the opening remarks, please welcome from DG Grow, this is Head of Unit, Madame Barbara Bunsovito. Barbara.
Ladies and gentlemen, it is an honor to open EU-Taiwan Smart Manufacturing Seminar. Industry is one of the pillars of the European economy. The manufacturing sector in the European Union accounts for 2 million enterprises, 33 million jobs, and 60% of productivity growth. We stand on the brink of a new industrial revolution, driven by new generation information technologies, such as the Internet of Things, cloud computing, big data, robotics, and 3D printing. They open new horizons for industry to become more adventurous, more efficient, to improve processes, and to develop innovative products and services. Recent studies estimate that digitalization of products and services can add more than 110 billion of annual revenue in Europe in the next 5 years. New technologies are also crucial to lead the recovery out of the COVID-19 pandemic. As you're aware, the pandemic caused a significant impact on the European and on the global economy. It has highlighted that a strong economic base is now more essential than ever for supporting the resilience of our economy and ensuring inclusive and sustainable growth, competitiveness, and jobs. The role of smart manufacturing and digitization is pivotal. This is why the European Commission is proposing that Member States mobilize 20% of their investments under the recovery plan on the digital transition. The EU has already very good cooperation with Taiwan in this highly technological area. The share of EU exports to Taiwan of semi-finished products, machinery, and equipment confirm the EU as important industrial supplier for Taiwan's industry. The EU has a strong industry producing more than a quarter of the world's industrial and professional service robots, all of which increasingly rely on artificial intelligence. But Europe can only reap the full benefits of artificial intelligence if this is available and accessible to all, and if industrial developments are in line with our values and focus on human-centric artificial intelligence. This is why the European Artificial Intelligence Strategy has set ambitious investments targets. This is also why we are working on the update of our regulatory system to make it fit to new technologies. In particular, we are updating the Machinery Directive, which is the main legal framework addressing the safety of a robot, and a proposal is expected to be adopted by the European Commission in 2021. And it will mainly aim at addressing the risks stemming from new technologies. Finally, we are also encouraging stakeholders to define new standards or update existing ones, for example, those on additive manufacturing, 3D printing, industrial and services robots, in order to have the technical benchmarks for the safe rollout of new technologies and thus facilitate access of all potential users, especially small and medium-sized enterprises. Such research projects I refer to, the regulatory and standardization developments, are among the topics on which we would like to continue our fruitful cooperation with our Taiwanese counterparts in the newly established working group on robotics. Alongside, the European industry leaders and clusters present in Taiwan are willing to work with the government and industry players to nurture and develop talents to make smart manufacturing a reality. This EU-Taiwan seminar provides not only an opportunity for business to share their advanced technology, but also a platform for EU and Taiwan to exchange policies and experiences and to uncover new opportunities for cooperation. Let me highly welcome this cooperation and wish you all the best. Thank you very much.
Thank you very much, Barbara. Thank you. That was Barbara from DG Grow. Ladies and gentlemen, and now also for the opening remarks from Taiwan Automation Intelligence and Robotics Association, please join me in welcoming our director, my boss, Director Song Kai-tai. Director Song.
TECO Electric and Machinery, Mr. Dennis Chen, Assistant Vice President, SIG AG, Mr. Volker Groko, Senior Vice President, NexCOBOT, Ms. Jenny Shen, General Manager, Dassault Systèmes, Mr. Samuel Xu, Industrial Process Consultant, Senior Manager, Aerospace Industrial Development Corporation, Mr. Tiansheng Wu, Chief Technology Innovation Officer, ABB, Mr. H.T. Zhong, Global Service Segment Manager, Electronics. Good afternoon, friends from Taiwan, and good morning, friends from EU. I'm Kai-tai Song from Taiwan Automation Intelligence and Robotics Association. It is my great pleasure to have the opportunities to have all of you here. Welcome again to attend EU-Taiwan Smart Manufacturing webinar. Due to US-China trade war and COVID-19, which extremely hit the global economy, but this also brings new opportunities for the industry to reorganize the supply chain. Taiwan is the top 5 of the major export countries of global machine tools. We have a stable supply chain with standard quality, and most importantly, integration services provided with multi-brands and the industries. To create the cooperation opportunities between EU and Taiwan in smart manufacturing, we like to gather all the industry partners in EU and Taiwan to see how we can do together. Today, we have TECO Electric Machinery, NexCOBOT, and Aerospace Industry Development Corporation from Taiwan, and SIG AG, Dassault Systèmes, and ABB from EU to share the experience to audience with the latest trends, cases of factory automation and digitalization, system integration, and smart component. And if you are on Tailora's B2B platform, which is www.tairoab2b.com, you will see the opportunities to appoint button, and welcome to click it to have more opportunities to interact with the speakers of the day. Lastly, I wish you have good health and all the best. Enjoy the webinar. Thank you.
Thank you very much, Director Sung. That was my boss, Director Sung from Tyra. Thank you for the wonderful opening remarks. Now, Director Sung has mentioned a website that is www.tyrab2b.com. Click on the website and you would also see our entire product line in detailed description. Now, ladies and gentlemen, it is time to move on to our presentations, in-depth presentation for the day. Ladies and gentlemen, our first presenter is from TECO. This is Mr. Dennis Chen. He's the Assistant Vice President of TECO, and he would be talking about AGV solution for smart service and material transportation application. Dennis, all yours.
Yes, ladies and gentlemen, it's my pleasure to share with you about AGV in TECO. I'm Dennis Chen. I'm in charge of the Intelligent Automation Center in TECO. And first of all, I'm willing to introduce what the TECO group is doing, and then I'll share the ideas. We developed the smart moving platform and the outcome of our effort. TECO was founded in 1956. At first, we focused on the motor manufacturing. The major range covered from the small motor below 1 horsepower, the small motor, and to a very, very large motor, more than 10,000 horsepower. Now the major business, including the home appliance, the power generator, the high voltage insulation systems, information and the communication components and the systems, and etc. We have some branch and facility located in the worldwide for global operation. And the manufacturing facility located mainly in Asia and America. And the others, including the Europe and the Oceania and Africa, it is the sales channel and the service center over there. Based on motor production, TECO provides more diverse products and services, as figured in the right side, including intelligent solution to serve our worldwide customers. I introduced the smart AGV system for manufacturing and service application today. We know the concept of the Industry 4.0 now, and we need a smart machine to support a smart production line and organize all processes to construct a smart factory. The material and the parts transportation is a key issue in a physical manufacturing factory. There are lots of items should be done in this process, like sensing, data acquisition, process monitoring, etc. The material flow control issue can include not only the material handling, but also information flow and the decision making. That is why a smart AGV system is not only the AGV. Therefore, we describe the detailed operation in a production line and show it in the picture. We identify 4 key items should be developed in-house. First, in a single operation area and short distance material movement, the material handling can be done with the help of the robot, cobot, conveyor, and the AGV or RGV, accompanied with the machine vision and the AI for unknown operation. We need AGV, RGV system to do longer distance transportation, and the IoT connect every item in the processes. When we focus on the AGV, it is not only the moving vehicle. There are a lot of issues. To build a physical AGV, to control it, the safety issues, etc. in the various and the dynamic changing environment, the AGV operation can benefit from the AI assistant. In this figure, we figure out that to build a smart logistic management system, the physical one is the AGV platform, including hardware and some control and sensing technology. In the task and the vehicle management side, the planning and the scheduling function and the monitoring ability for single AGV and the multiple AGV are important. The last one is the storage and the ASI's connection side. The communication ability is a must. So we can say that the intelligent AGV system is not only a single system. It must be combined in a full material handling system. Therefore, we developed the AGV system in-house and divide into 3 subsystems. The first one is the mechanical design, because we had to handle the design of the AGV to respond to the different application needs. And the second one is the electromechanical system. And the last one is the control kernel. That's the important one, that we can have a lot of applications based on the same platform, because we develop the technology in-house, and we can have a good architecture to share in different applications. With the support of the TECO's BU, we use TECO's components to build the AGV in the 3 layers, from the powertrain, including the servo motor, the driver, the gear reducer, etc., and up to the control of the system, including the PLC, the HMI, and finally, we do some application to accommodate with our customer needs. We can see that what a AGV platform, we focus on the tailor-made various applications based on the same platform. For the various applications, we develop a moving platform and the modular architecture for software and the hardware help us to respond to the new application needs rapidly. For example, we add on a trail collector on the moving platform. That means we can share it in a restaurant site. And we put it a guiding panel on a platform. Then we can use it in a public building to help somebody or some guy to looking for their needs and their purpose. In the other side, we use it in the industrial applications. Based on the same software and the hardware ability, we develop 3 kinds of the AGV in the industrial application, focus on the material handling and the transportation in the manufacturing factories. That is why we name it as a moving platform with a core technology kernel. No matter it is used in the service or industrial category, the modular architecture helps us to deliver different AGV for specific application in a very short time. So now we have another project right now, because we found that we have to do something from the AGV to the AMR, autonomous moving robot. That means that we have to integrate the robot with the AGV. Then with the in-house developed component and system, we're doing some system integration, including the driving system, the powertrain, and the control, etc. Now, for the application of the AMR, we focus on 3 target markets. The first one is the factory automation. The second is the wafer transportation in a clean room. The third is the medical and the healthcare application. Of course, this application must be cooperated with our customer needs. The AGV and the AMR can be used in many fields. The most restaurant is the service one. Most burger is a Japanese brand, and the TECO has the authority to deploy it in Taiwan. So the application of our service robot is delivered about 2 years ago in most restaurants. And the second one, the wafer transportation, is an ongoing project. We have already a lot of factory application cases today, and the system is an open system. Then it can be connected with other MES or WS system, so we can integrate in a full system for the Industry 4.0. I show you some videos to demo our function, including route planning, multiple AGV management, and some concept. But all these are physical implemented in our customer site. In this video is the AGV with LiDAR. But in the other places, we have some other functional items, so we can fit it into a very tight, very narrow space, and they can operate properly. To support our customer and speed up the maintenance response, we also develop a Fusion VPN monitoring system. It is operating in the most restaurants now. So we can monitor the service robot, how it operates in the restaurant space, and how they work. And if there has some malfunction, we can collect the history and to improve our technology and our components. For the future development, the more complicated application and to help easy setup and easy communication, the voice command and the visual recognition is an ongoing project. Self-navigation ability in a narrow route and a dynamic space is the key issue of restaurant application. So we try and test it in-house, and then we upgrade our software into our customer site. Then we can test it and modify it. I think the technology is not so difficult to use, but the improve and the suitable for each application field is an important one. We have another ideas. We have a very simple idea to test how a simplified system can help our customer to do job more easily. This is an example. We add some necessary component on a cart and modify some control function to do a try run. For example, a visual module, the powertrain, etc. And this is our demo video. You can see that without a we call it a follower, a car with a following function, then we can help the operator to move the heavy duty job from one to another site. So we are trying to do something easier, not a very high, very expensive one, and to help somebody can can implement this technology in everywhere. We also have the magnetic tape guide AGV, not only the LiDAR guided. This is, in the right-hand side, the video is implementation in our factory located in Guanyin. And we also found that there are some issues about the tape guide AGV, for example, the tape crash. So we devote some effort to solve this problem, and we find some solutions. Now, this demo video shows that the AGV can keep going 1 meter long without the tape signal feedback. Whatever on the straight or curved route. This is the test video in our office. In the left side, the dashed line means the signal is lost in the route. So you can find that the AGV moves smoothly even without the signal feedback. The AGV and the AMR can help all of us to do many things easily. The application like the food service, the retail, library, logistics, factory, hospital, hotel, security, etc. There are possible applications for the smart AGV solution. We're looking for cooperation with partners and customers. Thank you.
Thank you very much, Dennis, for this wonderful presentation. How nice. Robots serving you burgers. Looking forward to that. Thank you, Dennis. Ladies and gentlemen, and now for our next presenter, I would like to welcome online from Germany, from SICK AG. This is Senior Vice President, Mr. Volker Glecke. Guten Morgen. Willkommen. Can you hear me, Mr. Volker?
We're looking for cooperation with partners and customers. Thank you.
Thank you very much, Dennis, for this wonderful presentation. Mr. Volker, can you hear me?
Looking forward to that. Thank you, Dennis. Ladies and gentlemen, and now for our next presenter, I would like to welcome online from Germany, from SICK AG. This is Senior Vice President.
Mr. Volker, you're now online, joining us from Germany.
Yes.
Can you hear me, Mr. Volker?
Hello to everybody. I hope you can hear me. So I'm not sure if everything's working fine, but I guess so. Hello, warm welcome also from my side. My name is Volker Glecke. I'm working for SICK AG, and I'm very curious to be here today with you and give you an insight about what SICK is thinking if it comes to seamless integration of data. And I would emphasize here at the beginning that I never have talked before to Dennis from TECO, because if you now see my speech, you will see a lot of similarities and a lot of approaches that might be very in line of what you have heard so far. So,
Dennis, for this wonderful presentation. Can you hear me?
Yes, I can hear you, yes.
Thank you, Dennis. Ladies and gentlemen, and now for our next presenter, I would like to welcome online from Germany, from SICK AG. This is Senior.
Hello, can you hear me? Hey? Yeah, yeah. I have turned off.
Mr.
Sorry, I'm a little bit lost. Can you hear me? Can you hear me? Sorry. Okay, continue. Okay, sorry for that. I would like to give you insight about what SICK is doing in terms of data and how we can provide and how we can help companies like TECO to get more sophisticated solutions in the field. First of all, let me introduce myself. My name is, as mentioned, Volker. I'm working since 1995 for SICK. I started as a project manager in our logistics, so I know really our processes, and then moving along the chain of automation and ending up in a more customer-oriented department where I have some industry experts. We are not talking, in my sense, we are not talking about sensors. We are talking about really customer innovation topics that we would like to solve with our sensor signals. And this is more or less my mission in our company. A short outlook to SIG itself. So we have worldwide more than 10,000 employees. We are producing sensors. We are located in Germany, in Southwest Germany. We have 50 subsidiaries around the world. And as a foundation, as a base of our technology improvements, we have 40,000 sellable products, what means sensors, sensor systems, services, and also software modules. So this is on one hand side very nice to have, very comfortable to have, but on the other hand side, it's also it's a high complexity to handle for us. So how do we do that? Give you an insight about what we see as a trend, and that's now very much in line with TECO, what you have heard from Mr. Dennis. If you see the world as it is today, we have interconnection between the shop floor, the data floor. We have robots, we have AGVs, they all have to be interconnected. We have then also the transportation areas where we have trucks bringing goods to the factory, also bringing products to the customers, and then we have multimodal transportation, what means we have air freight, we have ships, and we have lorries. And so all and everywhere you are creating data, and the data are mainly created by sensors, and sensors are our genes. So therefore, how can we help you to be more efficient? And I would not go into the mega trends because you have seen them very clearly in the video at the beginning. But I would like to emphasize what's really the key of success in such a factory, in such a supply chain. You have to be flexible. You have to adapt yourself. You have to be scalable. If you have a volatile market, you have to improve capacities very easy, very efficient. You have to be modular. You should be able to stick everything together. Again, what Dennis mentioned with the ASRS systems, the conveyors. It should be easy to operate and easy to commission. You do not have everywhere the high sophisticated workers. They should be able to handle the systems, and it should be high available. You have to have a huge throughput, and it should be very transparent. And everybody is talking about this transparency is generated in the cloud, and that's definitely right. But is it only the cloud? Is it only the big data lake? Could you do something also underneath that? And I'm pretty sure that you can, and I will show you our methodology, how we approach this. And if you look at this picture, it's again very close to what Dennis showed. We have at the beginning the sensor layer, 40,000 sensors that potentially could solve an application that are generating data. And I used the example of HEV in the next layer. You see the navigation and positioning. It's an application that you can solve with sensor signals. Environmental perception, what's around you, load handling, what do you have on the HEV, but on the next layer, on the machine layer, you can interconnect all this data and you can get additional value like there is an obstacle in front of me, I cannot drive along. And this signal could you also provide to a fleet management system where you can decide to reroute the rest of your fleet, not going the same path because you know this path is blocked. And again, using this data that the path is blocked, you can also take some assumption in your enterprise system. Could I fulfill my targets for these days? How do I have to recalculate my complete supply chain? And this is all based on sensor signals, and the signals are already there, and it does not have to be that complex. I will give you now a few examples on the layers that I have strived here, and I will show you that it could be very easy to have the first results. Looking into our factory in Hochdorf, where we produce also the circuit boards, you see this trace, and you have all this circuit boards in the trace, and you have some gaps, and you have also some occupied spots. So how to detect this? You can use vision, you can use cameras, 3D vision, 2D vision algorithms, highly sophisticated, a lot of commissioning effort, and also very hard to handle. But you could also do it easy. Looking in the next picture, I have just put one row now out, and you see you have one sensor, he is detecting the tray is there, and while the tray is passing by, the second sensor is generating a profile that you can see here. And with this profile, you can easily say, oh, spot 5 is not occupied currently. And that means if you now serve this tray to the robot, and you put a few sensors in a row, easy sensors, not very sophisticated, you can easily detect where you have gaps and where you have the objects without passing by with the robot looking if there is an object or not. Very easy, but you use data that are already there. You lose intelligent sensor signals on a very low level. An example where we can support also, we have still a lot of manual workforces. We have still a lot of manual processes, but the problem is always, how could you increase quality? How can you increase efficiency? How can you increase the throughput? And if you look in the order entry zone, you put a parcel on a rack, and then you have to scan it. You have to say, where have I put it, in which slot? And then you transport it to production. And so a worker is taking the parcel out, is taking the product or the object out. This is all reported in the manufacturing execution system. But everywhere you have to put it in, you have to scan, you have to check if the position is right. You have to ensure high quality, you lose a lot of efficiency. And with a very easy system that we have developed, you can turn this around. So you have on a shelf, you have sensors that are looking into it if it's occupied. You put an additional reader on, if it's an RFID reader, if it's a barcode reader, a camera, it doesn't matter. And then you collect all this data and you provide this data to your warehouse management system and now or to your production management system. And now it's very easy. The worker can put the product underneath the camera. It's initiated. Which product is it? He put it into the shelf and it's done. Everything else will be done by the system. And you see here it's integrated via a SIG, that means a sensor integration gateway, to a ERP system, whatever it is. And so you have a high productivity in your manual work with a high quality without additional tasks to fulfill for the worker itself. So a very highly integrated solution in a manual process. And seamless integration of data means also, how do you handle your retrofit? How do you handle your already existing machines that you have in the field? You would not like to exchange the complete machines just to get a little bit more transparency. So which machine is standing in a row with which machine? I'm still there. Do I have to handle a product, an object from one machine to another one? How can these machines communicate to each other? They are monoliths, so they are often the old versions of machines. They have some control systems, but these control systems are not really linked. They are just isolated and doing that job in the automation business. And therefore, we have also investigated in being part of a standard. It's called Hermes, but don't care about the name. It's all about connecting already existing machines through these gateways with a standardized protocol. And now you have two options. If you have already a lot of data in your machinery, you can connect your control system to this gateway and you can then flow all the data in your ERP system and you can have a fully transparency about your supply chain, production chain, sorry. If this would be too complicated or you have not the data available in your system without touching any PLC that is already there, you can install wherever you would like to sensors, for example, cameras for barcode reading, that you get a transparency which object is in which machine processed at this time and which product is brought from one machine to another one in a certain time frame. So you have the full transparency in a retrofit environment by putting maybe some additional sensors, but on the other hand side, just enabling the machines to talk to each other to get the data on a standardized interface put together for your transparency. So SIG has really seen that this communication and this data transparency, having data from sensors available all along your supply chain is key. And therefore, we have, in the meanwhile, a complete bunch of controllers, but don't stick to our controllers. It's just the methodology that I would like to emphasize here. You can connect your sensors via gateways. And with this information, you can also transfer this information via the first, let's say, the first interfaces. You can also transfer this data if it's via LAN, if it's via wireless LAN, if it's LTE, 5G, whatever you would like to. And also you can process this data decentralized, what means on-premise in your facility or also in the cloud. You have the freedom to put the algorithms wherever you would like to. And we have very powerful also machines that can also handle 2D and 3D algorithms. RE was also, artificial intelligence is something that's coming into the game. So we need a lot of calculation power, maybe centralized, maybe decentralized. And to bring this all into life, we have an own ecosystem. It's called the SIG App Space. And the App Space is more or less a platform where all our customers can develop their own apps. And also SIG is developing apps. And then you can exchange your apps. You can, in a sense of modularity, you can put apps on different sensors, fulfilling different tasks with one sensor, just putting another app on it. And it's about your ecosystem, how you would like to have it. Would I like to have the app directly on the sensor? If the sensor is powerful, the calculation power is enough. Or would I like to put this algorithm in the cloud? Or would I like to put this algorithm on a sensor integration machine, a very powerful industrial PC? So with this ecosystem and with the sensors and with the connectivity, you have now the freedom to orchestrate your automation process like needed in your facility. So you are very flexible, you are very modular, you can support manual processes. You have the full range of opportunities to improve your processes. This is more or less, again, the SIG App Space methodology, where you can put different algorithms that you can see here on either on the sensor itself or also on sensor integration machine. Full transparency, full flexibility in your environment. And this is the core that we would like to fulfill. You see, I'm not talking 1 second about sensor performance. It's all about connectivity. And now putting all what you have heard on the final, let's say, on the last level. And SIG is very, very strong in collecting data in every facility and in every point of your production and your logistics process. And if you now see that you have a complete supply chain, the first picture that I've shown, starting from the sender to the receiver, what means the end customer, with freight forwarders in between, with production lines in between, with logistics hubs in between. What would be if you can get access to all this data along the complete supply chain? You always can see there is also data governance. We have heard that also at the beginning from Barbara, where she said we have to have access to all the data, to information, but we have also to take into consideration data governance. Who is the owner of the data? What would you like to show to others? So therefore, we are working in a collaboration with a lot of companies here, and we have created the international data space. An international data space is a standardized way to exchange data between different enterprises where you have to take care about data governance, for instance. And this is where we are aiming to, and this is at least the picture where we would like to go together with you, and where we have to go together, that we have an interconnected world, but we have the information always where it's needed in the right time and the right quality. It's not always putting everything in the cloud and we are fine. We have to have the information, the algorithms, everything there where it's needed. What means it could also be in a simple sensor. The flexibility, the modularity will be the key for the future. And then we can talk about AI and all the other topics that are coming on top, where we then solve the real applications. And we have to have always the complete picture. As a summary from my side, for us as SIG, and it's I'm personally absolutely convinced, we always have to have a holistic view on supply chains if we would like to have a very efficient, seamless automation. It has to be, we have to have the picture across everything, and then we can decide how to solve it. What means it could also be a very little tiny function on a device level that could really help us to improve our quality. What we should not forget, we have always users in this game. We have humans in these games, and therefore we have to have the human and automation interface have to be very, very intelligent. What means very easy to understand, very easy to adapt, very easy to control. And with that, we need the flexibility to create new applications, to create new solutions, and we have to place them where they need it. So we have to have a very flexible, tailored module. And as a final statement from my side, SIG can really help you to improve transparency, efficiency, and quality in all your processes. And we do not care if it's on if your problem is based on the sensor layer or if your problem is based in the cloud. We can help you, and we can analyze together with
smart manufacturing. Jenny, all yours.
Hello, everyone. I'm Jenny. Today it's a pleasure for me to be able to share with you the market trends and product solutions. And in 2012, actually, NexCOM started our own R&D development of both hardware and software solutions in EtherCAT Master and motion control. And we followed basically the open architecture, allowing our users and our customers to be able to implement secondary development on our solutions. So in 2018, NexCOM did a spin-off of two affiliates, NexAIoT, focusing on IoT automation solutions in Industry 4.0, as well as Industry 4.0 project execution, as well as NexCOBOT, focusing on robotics and motion control smart machinery solutions. So together we form the complete Industry 4.0 total solution. And in the post-COVID-19 era, actually we see the boom of smart manufacturing, and with the disruption of globalization, we see a trend of more localized manufacturing. So firstly, the increase of robot customization in smart manufacturing, we see more what we call industrial RPA, robotic process automation, integrating different forms and types of robots with CNC control or general machines, and also bringing these machine and robot data to the edge and cloud. And of course, robots are integrated with different application software packages. Secondly, we see the rise of what we call Internet of Robotic Things. And here we can see that more industrial robots and service robots are integrating AIoT, 5G, and this brings a lot of growth in, for example, AI inspection, smart warehouse sectors. And of course, with the rise of industrial IoT, actually connected machines and robots become the leading trend and mandatory in factory floors. We also see another new business model on the rise called robots as a service. And here we would include, for example, robot applications and cloud services in a subscription business model. And the third trend that we see is a high demand of robotic skills. So we see workforce training as well as curricula in undergraduate education more important for robotic. But while implementing industrial IoT, we've met a lot of difficulties in the past. And what are they? Actually, in a factory floor, you can see over 200 different industrial protocols from machines or robots. And this leads to difficulty in the closed architecture of having these machines or robots talk to each other and communicate with each other. And it's difficult to get data and retrieve data from these machines. So unlike smartphones and PCs or IPCs, in which they follow what we call open architecture and industrial standard, the industrial IoT also needs to go for the open architecture design so that robots and machines are able to talk and bring data to the edge and cloud. So the solution to this that we would like to bring is the Open Standard Industry 4.0 ecosystem. And this is what we call the IAT 2000 Cloud SCADA. And with this solution, actually, we implement the open architecture following Wintel or Lintel IPCs, as well as the industrial standards. So you can see industrial standards in factory automation, machine automation, robotics, and also different types of machinery, as well as in the edge side, bringing the data from the OT layer up to the cloud. And in smart machinery, actually, NexCOBOT has developed our own EtherCAT-based control algorithm in different sectors such as CNC control, in general motion and general machinery, as well as in industrial robots and as well as in AMRs. So all this based on EtherCAT open architecture. And for existing solutions in the production line, that are using, for example, the KUKA ABB or Siemens, different robots and machines. Actually, we can also leverage the gateways for smart machines and robots to collect data within the production line and the factory floor. I think the beauty of this is that we are able to offer an open control engine that allows users to be able to add on their application software package. So the control engines in different like CNC's general machines robots can allow users to do secondary development with our development tool, as well as add their add-on application software package to create a complete, what we call industrial RPA solution. So if you're planning on building your own customized industrial robot, actually NexCOBOT provides the building blocks of industrial robot system, including the robot control mainboard, robot controller, control system cabinet, the teach pendant, as well as software packages, and also the smart robot box, which is the robot gateway for data collection. And of course, Open Standard allows us to be able to make friends with different forms and different types of robots, as well as servo motors and drives. To sum up, actually, NexCOBOT would like to build and partner with the different partners in the ecosystem, industrial IoT ecosystem. So here we divide into 4 different layers. Level 1 is the automation equipment partners. So we work with these automation equipment partners, bringing the OT data to level 3, to the IT layer, as well as to level 4, which is the cloud and application services. Okay, so actually the key here is we connect the machines and robots through the different gateway solutions that we offer. Here you can see a range of different gateways, from device to PLC to the CNC wireless robot gateways, HMI, and predictive maintenance, the different vertical application gateways that we offer to our partners. Okay, in the following slides, I'd also like to share with you a few application stories and success stories we've implemented in the past. Actually, this is a solution implementing the integration of CNC and robot into a manned production line, so that users are able to place their orders directly online, sending the orders to the remote production line. And this integrates the ERP and MES, also with the intelligent cloud dashboard. So bringing all the equipment data to a real-time dashboard for live monitoring. And in this system architecture, actually, before implementation, the CNCs and robots in the line were using different brand controllers speaking different protocols, so it was difficult for them to be able to communicate. But after implementation, actually, they were able to integrate, communicate, and easy for maintenance, so easier for system integration. This successful story is on automated 3C production line. So this customer actually manufactures servers and laptops, and before implementation, of course, they had a lot of labor workers in the line. But after implementation, we built a modularized production line, allowing the robot and motion controllers to integrate with advanced and different application software. So for automated labeling machine, for automated packing machine, for example. And we also implemented machine and robot gateway to provide predictive monitoring and also data collection of the production line. This next one is also very interesting. It's for a smart food production solution. So this food company is producing dumplings and also spring rolls and wontons, and they export these to over 112 countries worldwide. Now, the business model has migrated to what we call machine rental and subscription business model. And after implementation, actually, they were able to, let's say, increase their capacity by 20 to 50% in terms of dumpling output. And here we implemented the IoT gateway solution so that they could real-time monitor the vibration sensor and motor status, so preventing machine downtime and also collecting real-time data. This successful story is on smart packaging sorting and warehouse system. So we've integrated smart conveyors and also using robotic arms for package sorting, barcodes to monitor the inventory status and machine status. So the robot and motion controller basically increases the package sorting efficiency. And of course, with the implementation of the Smart Robot Gateway, it collects data from the conveyors and also sends the data for real-time analytics. This one is on spray painting, so there was extensive discussion on AMR. I think this will eventually be a very hot topic. Actually, this implements a controller as well as AI algorithm for spray paint and AI vision, all in a robotic control system. So integrating the motion control as well as AI vision object recognition inside. This last successful story is in our own production, and our production line actually, I think one of the key elements of Industry 4.0 is visualization, and here we've built our own enterprise war room. So you can see on the bottom side we have all of the visualization on the OT layer, so including our facility monitoring, our production line real-time data, as well as the production line monitoring, energy efficiency, predictive maintenance. And on the IT layer, we have the ERP MES live data, as well as the on-time delivery, warehouse management, and inventory management. So all these in the past used to be monthly reports, but now they can be, let's say, real-time, and every 5 minutes they are updated. Okay, so this wraps up my presentation. Thank you for your attention.
And thank you very much, Jenny Shen, General Manager of NexCOBOT. How nice. Robots for dumplings and wontons. Yum, yum. Ladies and gentlemen, moving on to our next presenter. This is from Dassault Systèmes Taiwan Senior Manager, Mr. Samuel Shi, talking all about 3D experience platform. Samuel.
Okay, thank you, Andy. Now I want to share you with the budget train technology, how budget train technology to improve manufacturing. So we talk about smart manufacturing or intelligent manufacturing. One of the key technologies is cyber physical system. So all the manufacturing is starting from the design. So usually you have a virtual design. You design your product, you design your more tooling, and you define the whole system engineering and then simulate with validation. So when you complete your design, you will start to move to digital manufacturing. It means you want to lay out your the factory in 3D, and you have process planning, and you can have design your resources and simulate your assembly and create 3D work instruction, etc. So, and then you will move to your shop floor. So you have MES for your manufacturing and operation management. So here you will have your shop floor management and your the quality management and the material handling. You have all the automation and all the system connected to your the device. So you collect a lot of data. So and then you want to have big data analysis. You want to identify your issue and improve your performance. So then you come back to your digital manufacturing. You want to simulate and find out the solution. Even sometimes you need to go back to your design to change your design. So this is cyber physical system and from design, manufacturing, and operation. So Dassault Systèmes have provided a 3D experience platform for the digital design, starting from structure design, system design, electrical, and the software. So everything you starting from getting your requirement, and you define your requirement bond, and define your the functional architecture, logical architecture, and then you start to design your prototype. You build your design bond, and then release to E-bond. So then during the design, you have many simulation like structure simulation, CFD, electromagnetic simulation, even some topology optimization. So when you simulate and validate your design, and then you can move to your digital manufacturing. So you lay out your production line virtually, you design your tooling, you have your manufacturing plan process, and validate on your assembly in 3D. Even you have many automation device like robots, CNC machining. So you will simulate all of this kind of thing, and then you can ready to move to your shop floor. So in the shop floor, you have your master production plan and detailed production plan, your material management, and you connect to all the devices. So you collect all the data. So then, and you can leverage our solution to improve and optimize your production. So let's take a look at how solution in each phases. So the first, take a look at the design. You build a digital twin of design. Digital twin of design is beyond only 3D. It should be include all the system, all the control unit, your hydraulic, your electric. So you can see everything in 3D. And when you are well designed and validated, then you move to produce your product. So now you have a complete virtual model of your physical product, and then you can connect them together. So you can collect all information from your robot, your puppy, and then send back to the 3D platform. So you can you got all the data. You can simulate all the movement and think about how to improve your production. So you could drive the puppy from your digital twin, and also in the reverse, you can send your signal from your physical data back to your virtual twin. So this is the concept of digital twin of design. So how does it work? It's not just only 3D. So it's include, you need to define from your requirement, and you need to define your functional model, and you define your logical architecture. And in logical architecture, you define all the necessary components, include your control unit, include your power, include your mechanism, and you have a mass model for the system engineer. So you are well define all the components, and then you can then it's ready for you to simulate the whole system virtually. So with this kind of technology, you can well define your product in the early stage. So when the simulation is complete, actually you can perform a software in the loop, hardware in the loop. For example, now you have your ECU, your control unit printed and put into your prototype of steering wheel. And then the steering wheel can connect to the virtual version of your product in the computer. So you see the signal has sent to the virtual car in the screen. So with the virtual twin, you can have innovation design. For example, you can see here, you want to validate the car to turn around in one point is with electrical car. So you see, you have on the innovation design, and you need to do well define it and validate virtually in your virtual twin. So it's not just animation, it's just actually a simulation. So you can get all the performance data from all your components into the speed, all the data, the driving force, and all the data necessary. And you can define all the scenario, how your cars go, is in the city, or in the mountain, or in the environment you want to drive. And especially you take a look in the city, it's very difficult to park your car. So you could turn your tire 90 degrees and just drive your car very easily to the small area. So all this is define the virtual twin of your design with all the system. So you can, before you produce it, you can well design it and define all validate all the design. And then you can move to, and then you can move to your production. So you can build your the working share. So you have your robot simulation. So you can have a offline programming. You use your robot for the spot welding, the arc welding, the painting, and riveting or material handling for assembly. So we are talking about the co-robot for human to work with robot. So you need to have, you can have the ergonomic simulation with a human to co-work, to define how you can work with the robot. So everything is simulated virtually in your digital twin cockpit, your virtual twin. So when you can validate all the manufacturing procedure and then send your NIL to your robot. So this is the working share. Actually, Dassault Systèmes is focused on the cyber system. And we work with all key on the cyber physical vendor. As you can see here, we have a wide alliance with ABB. So we work together, we bring our the CPS solution to our customer. So in the working share, you can see we can simulate all the movement and the beneficial process with each kind of robot and simulate it. And after that, we move the program, send the program to the machine, and then start to manufacturing it. So everything is could be done virtually, validated, and you could detect any crash in the early stage and make sure your product could machine successfully in your working share. And also you can have not just a working share, you can extend to a production line. For example, you are on the assembly a car and on the whole car body assembly, and you can ship it the multi-robot on the same production line. And you can also add the human in your production line. So now you can see in the car assembly line, you can define the assembly procedure, how you assemble your the car seat, dashboard, and what kind of tool you need to use, what kind of procedure, and when you deliver your material to your workstation, and you must make a line balance to have an equal cycle time during your production line. So everything is validated virtually, include the human. You make sure each kind of human they could work into the small space, and how they could comfortably use their tool. So when everything is validated, you can move this into next phase. So as soon as you build your virtual twin, you can experience with VR, virtual reality. We can leverage the HTC Vive or HP, ASUS, the VR device. So no matter you are in design phase or in manufacturing, digital manufacturing phase, you can just plug in your VR device, and then you can experience your current design, your current manufacturing process. So you can see how the plans lay out and how each workstation is working. And sometimes you might have a different proposal, and then you can send your different proposal to your sales worker, to your manager for design, for review, for a decision. So we could cover from the design and manufacturing, just plug in the VR device. We don't need a post-process. Usually for many tools, they don't have the capability, so they need to send their 3D data to animation tool and have post-process. But within our 3D experience platform, you just can plug in and see what you have designed and the manufacturing. So you might ask what happened to an existing factory for 10 years and 20 years. It's a big effort to build everything in computer. So we are support the newest the 3D scanner technology. We support E157 format. It's been the current scan can scan the detail about the cloud pouring with color, with lighting. So you can quickly just import your 3D scan data into our 3D platform, and then you could get the virtual copy immediately of your factory with detail. And then you can split your point cloud and define like a product. You don't need to review on all the equipment and the facility and the construction in 3D. You just split, and then like a product, you can define it. So you can search your air compressor. You can know who is your vendor, when you want to have a maintenance of the equipment device. You can quickly have your equipment maintenance. So as long as you have a virtual copy, and then you can revise your factory, renew your factory digitally. So for example, I just remove these areas of point cloud, and then I replace with my 3D model, and then you can simulate how you work in the production line. What is the throughput with 3 person or with 9 person? What is the utilization rate of each equipment and human, and simulate all the movement of the human. How can they work safely? Can they will not hurt get hurt? So all these the copy we can down in the virtually. So when you have full simulation, and then you can move to your production line. So we are support on the AR, so you can put on your AR glasses. So all your 3D instrument design with digital manufacturing, and now you can connect to your AR device. So he will guide you how to assemble your part, and you could check each item, and he will lead to you virtually to assembly, to the assembly or production or any operation in your factory. So this is our technology to extend from digital manufacturing to your operation line with AR technology. So, and now in the production line, in the shop floor, you have MES to manage all the work instruction, order, and you're connected to all the machine. And in the same time, you have a virtual version of your operation. So this is the digital twin of your operation. So you can see from the screen, from your iPad, you find there a red line in some the workstation. You take your attention. So you can take a look, and you find there is run out of the material. So you submit instruction to deliver the material to the workstation. So the red line turn to green line. So you have a virtual copy of your on the production line. So you can easily for you to manage all the facility virtually. So it connect to your the operation in your shop floor. So you see it had there another red line. You can find and click and find all the information. It tells you the temperature is too high. You need to send someone to take a look about your waiting station. So this is a technology we are using to have a digital twin of your shop floor and connect to your MES solution. So usually in the factory, you find something wrong, you have discussion, you have link discussion. So we have a 3D link discussion. You can, on the touch screen, you just write down the issue and assign the issue to your member, and virtually you have a 3D link for your discussion. And the most important is all the issue can be tracking. In the paper sticker, you cannot tracking it, you cannot keep it. So this is truly digital twin of your operation. So let's take up one example of our customer Airbus. We have started a DDMS project last year, and they want to use the digital twin to design, manufacturing, and support their next generation of the product design. So you can take up how they are doing, and they want to build a digital twin of their product system is being the design. They want to build a digital twin of their internal system in manufacturing, and they also want to build digital twin of service. So you can see they could tracking from their requirement and deploy their functional architecture, and then define their logical architecture, and then start to design their physical product. Everything is linked together with the product, process, and resources. So now they have some the application in the digital twin solution. So you can take a look at this service. So they have non-destructive the correction testing data. And all the data is linked to their 3D model. So you can easily identify where is the problem, where is the correction, and you could build everything in the 3D. You can define, you can run the hub part and hotspot, and define your strategy for the service strategy. So everything could be seen, could be used and leverage our 3D data. So the last slide, with Dassault Systèmes 3D experience solution, we can starting from creative design, engineering, simulation, even connected to your marketing event with the virtual data, with your product stream. And then you have a manufacturing stream for process planning, work instruction, robotic, CNC machining. And then you can simulate your workflow, your factory simulation, and have MES to manage your operation. And then the most important, you can leverage your virtual virgin to improve and optimize all your manufacturing with 3D experience. Thank you.
Thank you very much, Samuel, for this wonderful presentation. Samuel from Dassault Systèmes, Taiwan. Now, ladies and gentlemen, that wraps up our session 2, of which the topic is our cooperation between systems integration and machinery plant. As a reminder, when the speakers are speaking, you may notice on screen there is a QR code. Scan the QR code. If you have any questions, leave the questions, and we will have them answered in our panel discussion coming up after all the presentations have been completed. Now, ladies and gentlemen, moving on to session 3. This is all about implementing Industry 4.0, building up your smart factory. And our next speaker presenting for us is from AIDC, Aerospace Industrial Development Corporation. This is our Chief Technology Innovation Officer, Mr. Wu Tiansheng. Mr. Wu, please.
Thank you. I'm Tiansheng Wu from AIDC, Aerospace Industry Development Corporation. Hello, and should be good afternoon in Taiwan and good morning in Germany. Now, I would like to introduce application of smart manufacturing and AI in the aerospace industry. First, please allow me to introduce AIDC. Our core business includes defense, commercial aviation, and engine. For defense, that is very important. We not only upgrade but also maintain our advanced jet trainer F-16 and include our IDF fighter. Of course, for the commercial aviation, that is our customers such as Airbus, Boeing, and Bombardier, and the Japan Middle Region jet. And also for the engine, our customer includes GE, Louis, and also Freight, such as. And now my presentation would cover 3 topics. First one is about intelligent AIDC platform and system. Second, intelligent manufacturing and also AI application in our company. So you will see some picture. It's our advanced jet trainer. And first one, I would like to introduce the challenges in aerospace industries. So that is very special because we had the mixed process and the products in one factory, even in one production line. So you can see this picture from capacitor process. With the 10 major processes, the first one is material and then cutting and then let up, curing and demold, machining, gluing, inspection, polishing, and the assembly. Just production line, each process not only include one machine, but more important, they have many processes and many machine tools, and also they have different kinds. And also our characteristics are small quantity and many kinds. And more important, they are high price on products. So it is a very special to implement Industry 4.0 to this kind of production line. So before I introduce our intelligent AIDC system, I would like to introduce the production tempo, because production tempo is very important in one production line that will control or the tempo of the production. So we develop ourselves. First one is on the top level. It is a first level scheduling based on and for company, because we have many kind of projects and products from the different customers. So it's very important to scheduling and to predict the production quantity and also the material requirement on demand. The second level is based on each factory That means based on the first level prediction, then we needed to predict on the second level. So we need to do the smart scheduling based on one factory. That is what we call advanced process scheduling system. That is based on the working order. And the third level, the scheduling is based on each work center because it is very important based on some task priority and the dispatch. That usually we call the manufacturing execution system. So based on this three-level scheduling system that can smooth the production tempo. And also more important, we need one production floor line system because we can monitor and feedback the status of each work center because we can handle some kind of bottleneck in the production line. So based on this four architecture, then we can let the production smoothly. And next one, I would like to present our AIDC. We call Intelligent AIDC platform and system. So in the bottom layer, so it's based on three layers. In the bottom layer, all the machine tools are integrated into our AIDC system. So we had different kind of machine tools, equipment, the kind of things, and it's based on the IoT sensors and the network we call ICE. And second layer, in the middle, we develop the AI ware that is based on digital integration platform. So we can integrate different kind of system and the data into this platform we call the PaaS. And on the top layer, it is an intelligent application system. So all application system is based on the web service. So that kind of service will be easy use and also friendly. It does not need any training for all the workers. So this is many kind of the application system we develop in our system. It is to secure quality, increase efficiency, and reduce cost. Okay, and also this IADC, it is also related to the supplier and the customer. It's very important from the customer. It's based on the demand, especially the firm and the purchase order. And also we provide the products and innovation, that kind of things to the customers. So all the core system is the IADC system, and also include our backbone system such as the ERP, POM, MRO, and also AIDC engineering system, AIDC manufacturing system. So it is based on the three-layer AIDC system to cooperate with the supplier and the customers. And now, let me introduce the IADC in detail. So first, I would like to talk about to increase our competitivity advantage. So quality is very important. It's always the first priority in the aerospace industry, and then efficiency and cost to increase the international competition. So based on this, we had intelligent machinery that's based on the hard capabilities, such as the equipment, the machine tools, such kind of things. And second is the intelligent manufacturing. It's based on the soft capabilities, such as the SOP system, process, flow chart, that kind of thing. And the third one is intelligent management. That's based on the human, because the human is important. So these three major categories is our major core system in the IADC. And first one, I would like to introduce intelligent machinery. It is the major key success factor is based on notified problems and prevent errors and prevent production. So these three key measures is very important. So we use the IoT and cloud and the big data to enhance this kind of three key success factors. And in ARDC, we had Saru site, which is site in south of the Taiwan, and the Taichung site in the middle of the Taichung, and the Gangshan site in the south of the Taiwan. So those machine tools are all integrated into the IARDC platform. And two major uses. One is about the environmental. So we use real-time monitor system to monitor the environment, such as the article, pressure, temperature, and the kind of things. And another one is, of course, overall to monitor the machine tools. So we can see all the machine tools, no matter they are in south of the Taiwan or middle of the Taiwan. And of course, we can focus in or zoom in special one machine tools, to see the productivity, availability, or efficiency, that kind of thing, even the health or some accuracy of this machine, and the production status, that kind of things. So not only the overall, but also we can see one machine tools in detail. And then I would like to introduce and give one example about the intelligent manufacturing. So also three major success factors. First one is to digitalize manufacturing, and then second, predictable manufacturing, and then predictable quality. This is three major important things. And in the slide, you can see in the left side, that is before production, in the middle is during production, and the last one is before assembly. So before production, we can do some cyber physical system, that kind of thing in the computer before production to make sure the quality is correct. And for in the middle, during the production, that's very important to monitor the accuracy and the quality. And in the right side is before assembly. So use the cyber physical system to do the digital assembly simulation. It will be easy to know how to work out, how to assemble the product, especially this kind of complicated system. Okay, the third one is intelligent management. Also, three major key success factors: digitalize, use digitalize and visualize, and then intelligence. And also for the working level, so that's important to let them to do the self-management. For the first level leader, the kind of managers, then it is important for the learning management. For the high-level managers, key area management. So each kind of level, they have special thing to focus on and to manage. And also we use the visualize dashboard, such as the quality delivery and the cost and flexibility for each one of workstation. In that kind of information, so we were easy to handle and to know the productivity and the efficiency. And also we develop many kind of system, to help the managers and the worker to handle this kind of things. So it is one example for this. And the last one I would like to introduce is about the AI application in ARDC. Of course, each year we have more than 10 AI projects to implement and deploy in our company. So those projects have many achievements. And so I would like to share some key success factor. First one is objective. Always objective is the first priority, and then think about the application. So each kind of project, we define the objective and how to apply to the process or to the department. And second one, then we find the method and to find the AI model, and also to increase the accuracy. And the last one is data. So data processing is a kind of hard work and a dirty work. So it needs some of persistence. But this kind of professional domain knowledge in each process and each department is very important. So it is a good way to use the AI to systemize and to inherit those domain knowledge. And more importantly, keep in mind is the benefits. And also, I would like to share with some personal experience about that. When I talk to our team, each kind of project leaders, I would always tell them, don't do the iron train. Don't be the iron train. Name of broom, yeah. So that would be cut out your project. And also, you cannot be the epiphenom. That means you just broom once and never broom again. So, and the more important, it should be the orchid. That means you keep blooming, yeah. Not only each quarter, but also each year. So that is the AI project, very important thinking. So AI thinking, we also have some training, yeah, inside, not only for the manager, but also for the workers. And each kind of training needed to be trained with the question. So they needed to bring the question, come to the course. Otherwise, it cannot be selected. Okay, and also more important is about the application theme. So mechanism is more important. All the development is to apply in your process and your department. So that is also our vision is to be the intelligent AIDC. That means from the manufacturing AIDC to the intelligent AIDC. So that is all our goal. I think time is limited, so I just to introduce about this. Thank you.
Okay, thank you very much. From AIDC, this is our Chief Technology Innovation Officer, Mr. Wu Tianshen. Thank you so much for this wonderful presentation. Now, ladies and gentlemen, just a reminder once again, when our speakers are speaking, you may find a QR code on screen. Scan the QR code, leave your questions. We'll take care of them during the panel discussion coming up in just a short while. In fact, there's only one presentation before the panel discussion, and this is our final presentation. This is from our next speaker. Please join me in welcoming from ABB, Mr. H.T. Chung. Mr. Chung, all yours.
Good morning for those who are joining us from Europe. And good afternoon for those who are joining us from Taiwan. So, greetings. So, today I have the pleasure to join the crowd and those pioneer in the industry. We're able to present to you on the precise planning on robotics automation to enhance solid factory of the future. So, yep, let's go through it. Today, I roughly will bring you 8 agenda, and these 8 agendas are today's robotic, refreshment of the automation ideas, the future of the robotics, the new user experience, precision planning on robotic automation, precision planning on robotic automation, talk about the ROI as well, flexible manufacturing and the smart machines, big things but small step, the learning AI, and of course, last but not least, the takeaway. So let's move on. So today's robotics, just give you a one heads up. Again, some refreshment. On the Industry 4.0, we are talking about back to 2012, the handover, the first introduction of the Industry 4.0. that we able to bring out a new idea how to eventually bring up the productivity and push, let's say, the productions or even the deliveries to a new era. So let me have you to have the idea of the robotics today. So the annual installation based on the latest information shared by the International Federation of Robotics. I would say one line that we have slight decline, which is have the 273,000 unit has been installed compared to the year before. It was about 400 something. So I mean, even so, but looking at the operation stock of the industrial robots, the right-hand side, you can see that, overall worldwide, we still very much demand on the robotic power to push, let's say, the industry to moving forward to a more productive environment. Okay, so no worries, the demand is still there, but it's just a little bit curved there, we have to overcome that. Okay, and bringing forward, we have the future of robotics, the new user experience. I mean, in the past that we have a different using of the robot experience, but somehow, I mean, throughout the new International Federation of Robotics bring out the concept which is simplification, collaborations, digitalization. Those are the keys that will bring the benefit of the robot implementations. And that is also the same direction that ABB is moving forward. Okay, talks about the simplification. Yeah, today, if you look at the left side, that we have already have a new interface where introducing even easier automations interfacing with the robotics, and also talking about we have been kind of using a simple way to deliver, let's say, the simple instructions have been writing using the old rapids. Today is just having a touchscreen kind of things. And of course, that's the reason that we want to bring up the speed of the implementation and to ease the user. And second, collaborations. I mean, having a collaboration in the automation solution today is able to enrich not only the performance, but also the complexity of the solution. And it really unlocking a lot of new opportunity for us to really think beyond that the traditionals of the industrial robot implementations. And of course, having a human robot collaborations is somehow rather bring, the balancing of the line and also a new approach that how we can design our line. Yep. And also together with digitalization, that can computerize. If we think about Industry 4.0, computerization is one of the key, eventually to bring the whole process, not only from the, the machines, the jig, and also talking about the robot, and moving forward to have more big data, more sharing on the information, and make prediction on the line. So let me bring forward to explain those three ideas for you. Okay, so the ease of use, as you know that we have a famous robot studio as the background would able to help you to program much more easier, but looking at our new Wizard Easy Programming that eventually can even bring you a new user experience. Yeah, let's have a video on it. You can see like using the new interface, eventually you just by clicking, and you're having a shortcut and colorization will help you to ease which are the different stage. Yep. On top of that, you can see that by having a collaboration robot, eventually also bring the whole implementation or user of robot throughout a new experience. We call it the lead through. This is also another example that how it works with the collaborative robots. And what we have seen just now, the sample using a test tube that is already implemented in the US and also Singapore. Yep, thanks to our new generation of CPU of our controller. Okay, mentioning about Robot Studio, one of the offline programming, the idea is to have, let's say a pre-installation test, talking about cycle time, debugs, okay, create the interfacing with the different peripherals of the robots, the programming, to test out any errors during the pre-installation stage, that in fact to ease not only, let's say, the cost of the implementation, but also, of course, the time as well. Yep. Yeah, to ease you to easily understanding of the virtual commissioning, let's go to the video. Yep, this is from one of the factory in the Austria, one of the famous ABB solution center where provide, let's say, the offline programming to our customers. Yep, and this is a dedicated solution from ABB. Yeah, you can see that all the planning on the peripherals, the jigs, all this can be pre-tested and pre-programmed, before the installation. Yep. Last but not least, the last concept, collaborations. Okay, I'm proud to present this solution to you because this is one of the homemade solution. It's in Taoyuan, Jiashida. It's one of our pioneer industry where implementing the collaborative concept, not limited to the collaborative robot, but using some other peripheral products to present you the collaboration concept. Yeah, let's go through it. Yep, this is the open day where they have a successful implementing the collaborative and also information on the productions, and this is how the local Made in Taiwan solution. Now what you can see now is the assembly, the display, with human and robot interactions. This is one of the collaborative concepts. Now, and together to integrate with the sensor that you can see that, of course, is also the touch screen, scheme that able to bring you the collaborative concept. Okay, yep. Here, I'm proud to bring to you also another solution of AR viewer apps that recently just developed by the ABB Robot Studio. Yep. Let's share it. See how that people can eventually, in Chinese, we call it 纸上谈兵. This is pretty much something like that. That you're just looking at the VR and you have a visualize how the installations and how the production lines looks like. Yeah, but just having, let's say, the goggles on that. Yeah, using a phone, a tablet has become more common, talking about during the installation to visualize how eventually the actual size, at the location. Yep. And of course, think about social distancing. You can really share with your boss if you need approval. Yeah, just to share with her or him. Yep, just presenting using the AR and VR concept. Okay, I mean, for those, let's say, high-end solution, it somehow rather still brings back, need our support, our wide range of ABB products that able to cover a different length and also payload today. Yep, that will able to deliver a complexity of solution for you. Yep, and also last but not least, but don't forget, besides talking about a single robot as a product, eventually we also can give you some, let's say the offline programming together with some global resources and local service. And we have dedicated industry solution, which is like automotive, OEM, automotive tiers, related to like electronics products, food and beverage, and also some metal, food industry, and of course, healthcare, and last but not least, which is the logistics solution. Those are really ABB experience that we can able to give you a robotic automation solution. Yep, and to deliver that, we not need more than a software, the manipulator as a robot, and also the system, also ABB customized equipment, and also the people who have served you in a different country of 53 locations worldwide, 1,500 people. that will bring you a dedicated and functional packages where we know how in the industry to deliver a customization for you. Yep. Let's come into a little bit of the precision planning that today we want to talk about. Yep. So let's have an idea of a flexible manufacturing and smart machines. You know, through our videos, it explains better than words. In the video, in fact, you are looking at is a lot of the new applications that we have done through this year, which is including in the automotive, in the medical, and also in some sort of general industry, even like our home base, Switzerland, watch manufacturing. Yeah. Okay, now you're looking at one we call the implementing cycle. Okay, as you can see, those you have a different stage. Start from the far left, let's say the evaluation, the process optimization, simulation, installation, production, and maintenance and upgrade. And you can see after the upgrade, eventually it brings you back into process automation. Why? Because today, with the upgrade that we offer, we eventually can help you to increase, optimize your process, your production. But what is the line that next to it, or even below it? You look at it in the simulation stage. In fact, we have, let's say, able to have some solution for you to pre-study the line, the feasibility studies. You can check through it. And of course, during the installation, the programming, we can use offline programming, and we can even use the virtual training for you. And for the productions, the spare and services today, eventually throughout the Internet of Things, that we can eventually have some prediction software to get you to able to predict the failure or even the breakdown to act before it. So when the time that the robots or the solution have been aging, we also provide you the upgrades where to help you to optimize your processes or your production. But just one additional information which is sharing. ABB able to provide upgrade which is from, let's say, a generation 4 controller to a generation 5 controller. Those are really a value to a customer who able to maintain the, let's say, the assets or the products for more than 20 years. So I would say that with this complex process of precise planning and execution, with the new simplification, digitalization, and collaboration, eventually help you to even deliver faster. Okay, so I mean, as usual, when we talk about automation, we usually talk about ROI, the return of investment. So let's have, let's say, a simple refreshment. Yep, return of investment. So, basically we are talking about profit and benefits that divide with your investment that gets your return. Those are the money, right? But on top of that, besides of money, what do we care, right? Do we care about only operation costs, or we do care about safety, or we care about the morale, because we have a nicer factory, we have a less load on the people, workers, so the workers will be happier, or we care about the customer delivery. Of course, do we care about process optimization, failure, rework kind of things, or we do care about, last but not least, quality. Quality. So, we just basically care about this one, the labor, removing the people and getting some money back. Okay. So, I mean, this will be, I would say, some idea that just to refresh for the people who wanted to invest not only the robot, but also the automation. Yep. I have a question now. It's like, what's below the iceberg? You know, we thought that investment, cutting off people, that would be simple, right? Yeah, but eventually just look what behind it or below it. Okay, look at it. If you think about, we just only implement getting the people out. How about, you know, rework? How about talking about we have the opportunity lost during the only cutting off the people, getting rid of experienced people. We have to retrain the people. We talk about some capacity, again, missed out during the mismanaged, things like that. Or we have our bottleneck as well. Yeah, but you look at the bottom of the iceberg. Those are the things that we usually forgot. And together today, eventually with the simplification, collaboration, and digitalization, it brings you the good value of the investment. And at the end, what is important, you get a return of the investment, not only limited to the value, the cost, but also the quality, the cost, the delivery, the safety, the process, and last but not least, the people, the morale. So again, I know, just take the opportunity to refresh those investors who wanted to really make your people or your factory, you know, become more productive. Those are the QCD, SPM things that you really need to look into it. Yep. Okay, so yeah, just recap a little bit today. If we talk about only, you know, automation, and 4.0 eventually is our target, but eventually back to today, I would say most of the small medium industry, they are still pretty much in industry 3.0. But don't be sad, you know. These are the area or these are the path that you probably need to go through. So you might not need to like focus in industry 4.0, you know, talking about high-end solution, but yet you can look into like industry 3.0 kind of solution, which is back to basic, which is like just simple robot, uploading robot. Let me share you some, let's say some information. Look at the left hand, you know, the top left. 40 years ago, this is how the robotic system looks like, uploading system. You know, and look at it today, you know, below the left. No, this is today the solution, but would it really brings a lot of difference in terms of our outlook? Not really. But you look at the other side on the implementation of the robot population. Every year by selling all these standard solution, eventually the number of robots is getting lesser, so year by year. You know, what does this mean to you? Yes, we have somehow covered the basic, but yet what I need to bring to you is the next message, you know. Yeah, a big things, but a small step. We are moving forward from 3.0 to 4.0. So if you look at it, one of the solutions today is the self-learning of the software that we have to collaborate with ABB. So you can, and also with the Korean partner, you can see that how they eventually learn to pick up things using a different, let's say, shape or different product. Yeah. And this is also another one that we are using the deep learning of the artificial intelligence base to eventually to learn. And this has been using in Amazon. So you can see I pick up eventually a different shape, you know, without having hesitate to deliver and to identify, to sort it out. Yeah. So, yep, about the takeaway. So I just want to give you a heads up. You know, in today we have a lot of issues, especially like availability of the human, like also like changeability on the environment, uncertainties. But yet, you know, we really need some digital ability to remotely support the customers, especially having 5G. These are the current situation that we have, you know, having the after the post-2020. And we know that social distancing has been one of the topics where limited the mobility of the robot, mobility of the human, that you need to get the solution from the robotics or automation. And also talking about to have a remotely support, even though that you can't be there for your customers. So these are the challenging or the environment, that trend and demand that we have post 2020. Yep. And last takeaway, now just a simple chart that you have took just now a couple of seconds to look into it. I'm talking about, remember that we said about the investment. And most important is the simplification. In fact, it's already implemented and already built, integrated into each of the processes that I mentioned. and also collaborations is also inbuilt into one of our system. So it's everywhere. And last but not least, digitalization. If you look at it, today we already deliver you the simplification, collaborations, and digitalization. Okay, I think today's is, I covered most of the topic that I want to share with you all, not only in Taiwan and Europe, and thanks for the opportunity given. Yep, bye-bye.
Okay, thank you very much from ABB, Mr. Chung. Wonderful presentation. Ladies and gentlemen, we've wrapped up all of our presentations, and it is time for our panel discussion. Again, scan the QR code, leave your questions there, and we'll take care of your questions during the panel discussion. Ladies and gentlemen, we have a wonderful moderator for our presentation moderation. That would be Dr. Sung from Tyra. We will have all our panelists, and of course, one of the panelists is online from Germany, Mr. Volker Glecke. Okay, ladies and gentlemen, it is now time for our panel discussion. We have our moderator, Dr. Sung from Tyra. We have Mr. Wu Tianshen from AIDC. We have Mr. Chung from ABB. We have from Dassault Systèmes, Mr. Samuel Xu, and we have from NexCOBOT, Jenny Shen, General Manager, and we have from TECO, Mr. Dennis Chen. Please be seated. Please be seated. All right, ladies and gentlemen, I'm sure you have many questions. And now, ladies and gentlemen, it is time for our panel discussion, welcoming our moderator and panelists.
Good morning and also good afternoon. Our distinguished 6 speakers, our panelists here. I'd like to introduce again on my left hand, Mr. Tiansheng Wu from AIDC, Mr. Zhong from ABB, and on my right hand here, Mr. Xu from Dassault, Ms. Shen from NexCOBOT, and Dennis Chen from TECO Electricity and Machinery. Now we have about 30 minutes for this panel discussion. We have abundant materials, abundant topics has been discussed minutes ago. I think most of you maybe already have some questions or some comments regarding this webinar. Before your questions, probably we started with some interesting topics this afternoon or this morning in Europe about smart manufacturing. You see that in our discussion, we are very interested and I think very beneficial for our attendees today regarding what is the current trend of smart manufacturing in Taiwan and as well as in Europe. Is there any method to deal with the development for industrial applications for smart manufacturing? I think maybe our speakers, our panelists may give us some answers or some your visions on this regard. Maybe firstly, may I ask firstly our friends in Europe Senior Vice General President Mr. Volker, could you give some your ideas about what in your mind or what in your vision would be the current trend for smart manufacturing, maybe from Europe point of view, or as you understand, something related to Taiwan, please.
Thank you very much. So I think the line is not that good, so I have some difficulties to understand, but I think it's more about what is the key to have this smart manufacturing mindset and what do we have to fulfill. I think the main point will be that we open up our data silos, that we exchange data also to leverage the complete power of this data. And to leverage this, we have to work together and we have to step above our ecosystems. We have to have a holistic view. And for me, the mandatory thing in the complete discussion is really the user interface. If we cannot make it have a very easy user interface that also non-technical people can handle all that, it might be that we run in the wrong direction. So for me, the key is really availability of data, a holistic view, usage of data. All competencies have to be brought together to fulfill that and have a very, very simple and easy user interface that everybody can really have the advantages out of this smart manufacturing.
Okay, thank you. Next, in your wonderful speech introducing NexCOBOT, Ms. Shen, I noticed that you mentioned about the flexibility or something related to the future system integration on smart manufacturing. I guess maybe it would be interesting if you have some remarks on this, please.
Yeah, to echo to what Avoka just said about availability of data, I think it's fairly important. And in order to be able to collect data from these production lines, I think the key is how do we connect the different industrial protocols in the factory floor and production lines. And that was what I just mentioned on the key to smart manufacturing is breaking the barriers between the different protocol machines and breaking the barriers between the different protocol equipments or robots in the factory floor. I think that's the key to making smart manufacturing flourish, whether in Europe or in Taiwan.
Maybe our panelists, yes, please, Mr. Zhong.
Yes, just want to share a little bit just now as Mr. Song talked about the trend. If you look at the number of the robot delivered through the worldwide manufacturers, you can see eventually till 1718 is having a peak, you know, but later on 2019 is slightly come to flat. And now even with 2020 looking forward, it should be maintain or decline. You know, but that doesn't mean that, you know, this is the end of automation and robotics. Is no. Eventually, if you look at the post-2020 situation, like now Q4 or Q3 or Q4, yep, we really realized that the short of humans in not only the manufacturing, but also talking about people start to be, you know, really stay at home to keep safe. And with this situation that manufacturers, especially China, they really realized that, you know, having automation and robotics is one of the solutions we're able to bring the sustainability of the delivery, not only to the market, but also to, you know, beyond countries that were needed the goods. So I would say that this is just another beginning, but it's a different beginning, start with a different situation or condition. Yeah.
Any other comments from our panelists? Mr. Tencent Wu from AIDC, please.
Yeah, I think from now on, long-term tech situation is very important. Another one is, yeah, just you talking about is about the data. Yes, data is very important. It's also the company treasure. So I would add on one viewpoint. So first one is very important how to apply and implement to the company, to the processes. So first one is involve the data owner. Data owner is the first one. And second is the data professional people. They know about the data, they know the characteristic data. And then the third one is the data processing. Data processing, it needs persistence, it needs to keep go on. And then we can really and truly use those data and to add on the value to the process, to the company. It will bring us many, many benefits. That's my another kind of viewpoint. Thank you.
In the beginning of this webinar, we have the data that more than 300 attendees would like to see and join us in the webinar. And there may be some questions. Let me have a look of it. Oh, yes, this is the question. I mean, the first come, first answer, okay? So this is a question. The question is like this. If we want to apply AI in our factory, what are the most important questions that we need to ask ourselves? Firstly, how should we take the first step? This is very, practical question if we want to apply AI. Any panelists would like to give some comments or answer these questions? Yes, Mr. Dennis Chen, please.
Okay, I try to give you our experience in our factory. Because the TECO has more than 60 years old experience about the manufacturing of motor. And just as a lot of a company, there's a lot of old machine over there. So the AI, how we can apply the artificial intelligence in our factory, we focus on two things. One is the process stability. So we need to understand what is the key issues and the key parameters will affect the output of our production. Then you can try use the IoT technology to collect a lot of data. And after you collect a huge amount of data, you need AI because you cannot read it by yourself only. We use it in the prediction of our quality output. And the second one is the equipment or facility stability. We monitor a lot of machines in our factory, and we found something very interesting. Because we are not the equipment or facility builder, but we focus on what we are interested or the items or the parameters that will affect our operation. So we monitoring the parameters which connect with the quality issue and the machine stability issue first. And we try to use the tools about the AI to analyze all the data, and we found a lot of interesting. So I can suggest that if you can understand what you are care about, you can collect the data first from this point. It will be helpful for us. Thank you.
Yeah, thank you very much, Dennis. This is very interesting. You mentioned about the quality, the stability, and for me, I think most importantly, data. So from my side, I guess, identify the problem related to your quality or stability, then you turn to, could you gather enough data set from your process such that your AI tools can be applied properly and to get the expected results? Any other comments? And Mr. Walker, do you have any comments on these interesting subjects regarding the AI? I think AI, most importantly, you need to have some sensors or sensor systems for gather on-site, or I mentioned the data. What are your suggestions for the first step if a company would like to apply AI for their smart manufacturing, please?
Thank you very much. So I'm very much in line with what I have heard already. So first of all, I think you have to identify the problem. If you do not know what you would like to solve, is AI the right tool to solve, then you will fail. So identifying the problem is very essential. And then you have to understand the real problem. If you look at one spot, it might be the problem occurs somewhere else, and you do not talking about the problem. You talk about what's the outcome of this problem, and you're solving it at this stage. So having a clear picture about the problem, and then understanding how you would like, in which direction you would like to solve it, and which database do you need to solve it. And then at this stage, thinking about how you can gather this data. Not thinking a lot of data at the beginning is key to everything. You have to identify the real problem, and you have to identify what data do you need to find this, let's say, this failure in the system, and then to solve that with artificial intelligence. That's for me the key. Understanding the application, isolating the problem.
Yes, identify the problem and identify the proper or the useful data, and using the right sensors. Thank you very much, Volker, for your remarks. There are questions coming here, here, and I would like to turn to a little bit for the, Taiwan. We have more than 97 or 98% of the industries are small and medium-sized enterprises, and for these SMBs, and I think smart manufacturing will becoming even more important after the, let's say, the trade war or even the pandemic. I mean, your supply chains. For them, I think to adopt something is very important for smart manufacturing. Here, I have a question from our attendees of this webinar. The question is as follows. Today's topic in smart manufacturing, I would like to ask Mr. Samuel Xu, what's the key success factors to make digital twin? Any suggestions for Taiwan SMB? So this is SMB about digital twins. Yeah, Mr. Samuel Xu, please.
Yes. You see, you want to build our full digital twin from design, manufacturing, and operation. Actually, is quite complicated. For small medium enterprise, I suggested to start step from step. The first, you should starting from build your 3D environment. And you have a digital copy of your design or manufacturing environment, and then you could step by step to implement on the simulation technology. For example, you want to starting from build your 3D model and starting from simulate your production line, or you want to starting from product design and structure simulation. With all this 3D model, and then you have a chance to move forward to in the manufacturing line. So it is a huge effort to build a complete digital twin, but you can do it step by step on from the most easier portion, and you can handle one. And you also need a platform and some suitable software to help you to build digital twin of your product.
Yes, the platform and the tools, and of course some design CAD data related to the system.
Yes, design and manufacturing.
Manufacturing. Any other our panelists would like to say something regarding suggestions or for introducing the smart manufacturing for our small and medium-sized business? Mr. Jenny, do you have any ideas? I think you have in your slides. I noticed that very interesting topics related could be on this regards.
Yeah, actually, we have been encountered by many small, medium enterprises who want to go for digitalization. And I think the difficulty they are facing is because of the COVID, let's say, crisis. So for example, labor shortages, supply chain issues. So they would like to implement more localized production, localized manufacturing. So I think smart manufacturing becomes very important for these small, medium enterprises. But when they go into smart manufacturing, the key factor that they discuss with us is the ROI. How much do they need to invest in smart manufacturing? So the way to break through this is, firstly, we tell them the benefits of implementing smart manufacturing, increasing stability and also reliability, also enhancing real-time monitoring of their machines and production lines. I think the key is to take it step by step for the small, medium enterprises. First step is automation and then digitalization in their sites.
Thank you very much. For this question or this discussion, I would like to a little bit, temporarily stop here. Maybe we can get back, but because here I have a question for Mr. Tencent Wu from AIDC. The question is as follows. What most challenges in the smart manufacturing transformation journey? Share your experience. What would be need to prepare in advance to, get into this transformation journey to smart manufacturing? Would you please, Mr. Wu?
Yeah, that is a really good question. So the challenge always happen in company. I think not only in the AIDC. So the challenge should be how to communicate with the colleagues and the managers. So that is the first thing. So thinking, creative thinking, and then the mindset, that is the first one. Okay, and second one, digital system or digital technology is ready or not. So how to make it and how to improve it. And the third one, of course, there are always had room and area to improve. There are many major problems, and I think and we can improve. Each kind of department, they know about that, but how to inspire them, to do that and to accept the kind of new technology. I think that is also a kind of challenge. So based on these three challenges, so I think connecting, cooperating communication is important for the manager and the coworker. Yeah, communication is very important. So 3C is related to the ICT, and cooperation, because if we want to deployment and to get the benefits as soon as possible, so cooperation is very important. To cooperate with outside resources or even government resources or from the abroad, that kind of things. So it's kind of technology they are available. Then we can cooperate as that will be available and to implement first and quickly. And another is connecting. Connecting is also very important. Whatever, any kind of connection we can, such as not only the kind of equipment, machine tools and data and the backbone system, we need to connect not only the human, but also the all equipment or hardware or the software, soft capability, hard capability, anything try to connect. So connecting, communication, and the cooperation, I think we can solve the kind of challenges.
So the determination, so the decision or the understanding from the higher ranking managers or even the boards is important. You put it in the first place. But this is from maybe, I guess, from Taiwan side. How about from Europe? How about Europe? I think Europe is also, faster or even working on harder in this regard to has the transformation journey to smart manufacturing. What is your opinion regarding this? What can or suggestion to these interesting companies to get prepared for this transformation journey? Walker, please, could you give us your comments?
Yeah.
Please.
Yeah, thank you very much. So the first thing I would like to emphasize, when we have heard the speech from ABB, I think that was very much to the point from Mr. Chong. If you're just looking at the ROI of such processes or process improvements, or what you can, how you can improve with digital manufacturing, smart manufacturing, you have always to look at the people. And at the end, it's if management would like to bring in such new technologies, new ways, new methodologies, first of all, for me, it's pretty clear that you have to bring in all layers of your company. You have to bring the awareness that it's needed to be successful in the future. And it's putting value on every layer. What means ROI, but also every employee in the facility should have the feeling that this smart manufacturing approach helps to fulfill the expectations and the needs that you have in the company. And then you have to start small. And what I would like to prevent really is we intend in Europe always to put the smart manufacturing like it's rocket science. Yeah, it might be rocket science, but we have to break it down that it is easy for every employee in the facility. And if we cannot make it, if every employee is afraid about working with autonomous machines, then we have a problem. So first of all, we have to bring it down to a very easy, understandable level. We have to show value. We have to start small and smart, and then we can implement it in the complete facility to gain the complete value of the smart manufacturing methodology.
Any other remarks from our panelists regarding this? Okay, Mr. Zong.
Yep. Vocal, thank you for the highlight of the ROI. Thank you very much. Throughout my experience in the manufacturing environment, I just want to share a little bit just also how to conclude Mr. Wu's comment, because as my experience that I've been working in automotive before, so implementing lean manufacturing, or the other way we call the Kaizen. So in Toyota TPS, Toyota Production System, we believe in 4P. So it's a people, problem solving, process, and philosophy. So one of the things that I think is build up the philosophy among the people, then you can move towards one direction. So even though that is talking about smart manufacturing, you're talking about go back to those lean manufacturing, Kaizen, or even the Six Sigma, it's pretty much start with the philosophy and the people we're able to understand and push towards one direction. That at least, I just want to make it a little bit, I would say, pragmatic.
Great. We have many questions. We have, of course, many discussions already. I think we are about to reach some consensus regarding today's panel discussion on the aspects of smart manufacturing. Because time is limited, before concluding, I would like to invite each of our speakers, including Vok online, to give 1 minute short concluding on your path, on your point of view regarding this panel discussion on smart manufacturing from EU, Taiwan. Could we start it from Vok in the European side? Could you? 1 minute?
Yeah, 1 minute, very easy. I think talking about smart manufacturing, we have to start. We have to step away from the PowerPoint level. We have to start, and we have to start together. Our company can provide data. We can provide seamless integration. We need the application know-how of the manufacturers to provide together a joint solution for our end customers, and that's our aim, more or less. Thank you very much.
Thank you.
It was a pleasure to attend. Thanks.
Appreciate it. Then,
Okay.
Mr. Dennis Chen from TECO.
Yes, I think if we can understand what we are now and we are looking for a better future, then we can start from right now. So to understand what we are what we have, the difficult or questions right now, and to think about how to solve it. I think a lot of information technology and the AI tools can help us. So just do it.
Thank you. Jenny from NexCOBOT, please.
I think the major target for us is to be able to build the ecosystem of Industry 4.0 and to be able to enhance this trend and also to empower smart manufacturing with these open standards. Thank you.
Appreciate it. Mr. Samuel Xu from Dassault Systèmes, Taiwan, please.
Yeah, so most customers now, they talk about smart manufacturing, almost focused on the automation, equipment, and device. And most of them didn't think about how to simulate before you move into your production. So you might think about how to deploy your digital twin journey, starting from small step, and then even a simulation of device, and then the production line, and then the whole the factory. So the cyber simulation is necessary to improve your whole smart manufacturing.
Mr. Wu from TIDC, please.
Yeah, I think it's very important, big vision, to connect with your company vision and the strategy. Second one, small step. That's important, so you can cooperate with some others, and also based on the major problems or something we can improve. We always can find some area to improve. And the third one, of course, the benefits and application mechanism, because everything we do in the smart manufacturing, that's because we want to get some benefits, and also the application, then the mechanism can get the benefits. So always think about that. Then we can use the connecting, communication, and then cooperating.
Yes, Mr. Zhong, please. Yeah, sure. From ABB.
Hello. Yep. Thank you. I think whatever that I think over here that we have a lot of pioneers who talk about Industry 4.0. The deployment of the smart manufacturing, I guess, by having the pioneers all here, we're able to deliver a solution for you. But anyhow, my last advice I would say is talking about improvement. I can conclude in three S. One is speed. You need to have the speed towards, let's say, the challenges that we have to change it, the changing environment. You have the sense to improve. That to answer the first question, where should we implement the AI? You must have the sense to improve. Then you apply your tools, AI, smart manufacturing. And last but not least is the spirit. You must have the spirit to change, to getting better. Then you were able to overcome all the challenges that you have. So the 3S is what I want to deliver to you today.
I really don't like to miss this very interesting question just coming in. So you allow me just a few minutes. And for the questions, nevertheless, if we couldn't give you a satisfactory answer, you still can come to our B2B platform. Title our B2B platform, we can still keep in touch of this question. But I would like to continue with this very interesting question. The question is as follows. Any real-world example, quote, in dollars, quote, of cost-benefit, I mean the ratio, cost-benefit, in smart manufacturing before and after? The question is not long, but it's big, okay? Cost-benefit example. I think we have our distinguished speakers some experience. I mean, from the real world. I mean, the question, the real world. I mean, your experience. Do you, Mr. Walker also? This is coming in question regarding example before and after cost benefit ratio, and could be difficult to give the numbers, but any remarks on this from our panelists? Or Walker in Europe?
Yeah. I do not, to be very honest, I do not have the numbers, but I'm pretty convinced that if our production planning team is implementing such things, they have to argue through numbers. And we have put in place in Hochdorf, it's a small town beside the small town Waldkirch, where our headquarters is. We have a production line there, and this production line is really up to date if it comes to Industry 4.0. And the big advantage that we have, we can change the product that we are running through this production line in minutes, despite compared to the past, where we have to build production line for each and every product. And here we have really the synergies, and we have implemented that since 2 years, and it runs very smooth, and we are continuously improving that. So I do not have the numbers, but I can just say to you, if production is going this path, and really we show it in not only, as I mentioned before on PowerPoint, it's really in a real production environment, it has to pay off at the end somehow. And I do not have the numbers, but it seems to be a very successful path forward for the future.
For me, I think also maybe for our attendees, this is very convincing from your remarks. Even don't have number, but even more convincing. Okay, so much, you know, give us the encouragement about this. You know, European Union, Taiwan, the same. I mean, on the journey of transformation to the smart manufacturing. I think there are many examples happening, or even more, in the near future in Taiwan, also in EU. As I said, time is limited. We would like to conclude our panel discussion and also the webinar of this afternoon. And in Germany is morning time. Okay, I would like to take the opportunity to express my sincere appreciation for our speakers and also our attendees on the webinar. I hope you enjoy this discussion of today, and keep in touch through the Taiwan B2B platform and also other opportunities for further sharing of experience, and also move towards this journey of transformation. Thank you very much.
Okay, ladies and gentlemen, thank you to our wonderful moderator and our panelists. Smile and wave your hand, including you, Mr. Volker Geckler. Thank you. Dankeschön. Dankeschön.
Dankeschön.
Thank you so much, ladies and gentlemen. And of course, thank you for watching our EU-Taiwan Smart Manufacturing webinar. Ladies and gentlemen, our upcoming events include Europe-Taiwan Smart Manufacturing Supply Chain Application Sharing and Matchmaking event on the 29th of October, and of course, AI Value-Added Smart Manufacturing International Technical Webinar coming up on the 11th of November. 还有同时呢，在11月12号有2020年台越产业合作论坛，请您线上来参加。Please register by scanning the QR code right there. Thank you once again for joining EU-Taiwan Smart Manufacturing Webinar. Stay safe, and stay healthy. Thank you so much. We'll see you next time.